Hello fellow problem solvers. So today we're going to be doing a polynomial problem again. I suggest you try this. This is an intro polynomial problem. I suggest you try it out for a minimum of 5 minutes, ideally 15 to 20, not more than 40 minutes. If you'd like to go along with us, give it a go for the next 5 minutes. And here's the problem. So p of x, a monic polynomial with integer coefficients, if there are 4 different integers a, b, c, such that p of a is p of b is p of c is p of d is 5, prove there is no k, such that p of k is equal to 8. So, how are we going to prove there does not exist such an integer k? Assume it does. And if you haven't assumed so, take another 5 minutes now. So, what then? So, the thing we usually use when we have these polynomials is, well, if they are k, if these are integers, then it means that k minus a divides p of k minus p of a. And in this case, this is 8 minus 5, which is 3. So we have k minus a divides 3, and also k minus b, k minus c, and k minus d. All of these divide 3. Now, how many different divisors does 3 have? I invite you to actually pause here for the next 10 minutes and try to push the problem further. And here's the next step. So 3 is divisible by what? It's divisible by 3, by 1, by minus 1, and minus 3. If any two here were equal to the same thing, then we would have that, what's it called? We would have that a is equal to b, say, or a is equal to c, or a is equal to d. Or that we would have two a or b, c, or d would be equal, which would contradict them being different integers. So this means all of these are different, and then without any loss of generality, we can say, okay, so k minus a is minus 3, k minus b is then minus 1, k minus c is equal to 1, k minus d is equal to 3, right? They're all different. Now what do we do? I invite you to pause for another 10 minutes and figure it out. And here's the next step. So we haven't used the fact it's a monic polynomial at all. Like, so far we haven't used that. So we have these 4 points are all equal to 5. Let's see what happens when we have the polynomial p of x minus 5. So let's say q of x is equal to p of x minus 5. Then we know this polynomial can be written as x minus a times x minus b times x minus c times x minus d times some other polynomial r of x, which is also monic. So p of x is equal to this plus 5. But now wait, what is p of k now? Now p of k is going to be equal to, so k minus a, k minus b, k minus c, k minus d. So now we will have that, here we have an 8, and here we will have, like p of k is 8, and on the other hand, we will have 3 times minus 1 times minus 3. So minus 1 and minus 3 give us a 3, 3 and 1 give us a 3. So 3 times 3 times r of x, where this is also a polynomial with integer coefficients, right? That's what we have. And we have that this plus 5 is equal to 8. Actually not r of x, but actually r of k. And now rk is equal to 1 over 3. And now this is a contradiction that r has integer, what's it called, coefficients, right? That it's a polynomial with integer coefficients. If p of x, if like this polynomial q was divisible by all of these, which means when we get them out, we still get a polynomial with integer coefficients. This is a contradiction to this being with integer coefficients. And so we're done. This finishes up the problem, and as always, thanks for problem solving.